to repeat anything or go over anything, let me know. So what we're going to look at is kind of combining our mouse pressed, our mouse position, and everything into one sort of function that we can use to determine a button press. So we're going to look at how to interact with shapes, a couple different shapes. We'll look at circles and rectangles or squares. And as I mentioned, this is often referred to as collision detection. So this is how we know if two things are in the same place. And it's sort of the basic way on the computer that we can determine, if we're hovering over an area on the page with the mouse, and then we can program different interactions. So it's sort of an important thing to be able to do for any type of interactive or sort of graphics programming. So we'll start with a circle collision. This one is simple. We just have to determine the distance between two different points. We can do this using the distance function in P5. So if we look at the distance function, this basically takes two different points on the canvas and it'll tell us how far away they are. And we can use that to determine if our mouse is inside of a circle or not. And so that can be useful for creating a circular button or a circular interaction. So this is kind of what this looks like. This uses basic, Pythagorean theorem, a squared plus b squared equals c squared. We don't have to write that out because that's what the distance function does for us. We just have to put in the points that we want to compare. So we can see the mouse moving around. We can see the origin point here, and then we can see the distance between the mouse and the origin point. And if that distance is smaller than the size of the circle, then we know that we're in the circle. If it's larger than the size of the circle, then we know that we're outside of the circle. So it's a very easy way to determine if if our mouse is inside of an area. So we can create a button where we click on a specific part of the canvas rather than just like clicking, anywhere on the canvas. So we'll program this over here. So we'll call this circle collision. And we'll start with a little comment. Okay. So we're going to draw a circle on the screen first. So we'll say circle. And we'll just put it in the middle of the screen. So I'll put it at 200, 200. And we'll make it 100 pixels wide. And so we're going to want to save these values as variables. But we're going to sort of talk through the math, and then we're going to abstract this into its own function. So similar to how we made functions to draw the components of our landscape a couple weeks ago with like our clouds and our trees, we're going to abstract the logic so that we can make multiple buttons on our canvas. Okay, so we're going to start with mouse X and mouse Y, and then we're going to use the 200 and the 200 as the other point where we're going to measure our distance. So we're going to create a variable inside of draw. I'm just going to call this D for distance, and we're going to use the distance function. And again, the distance function gives us the overall distance between the 2 points. So we want to use the circle 200, 200. And so I'll put that as the first 2 points. It doesn't matter what order the points go in because the distance is going to be the same regardless of which direction you measure it in. And then we're going to put in our mouse X and our mouse Y. And to start, let's just draw that distance on the page. So I'm going to use some text. I'm going to put the D distance value in there. And I'll put this, I guess I'll just throw this in the middle of the screen as well. And so now you can see, or actually we'll have to put this below our circle if we want to see it. And so now you can see that distance. It has a big floating point. So let's just round that. So we just see just the whole number. And let's make it a little bit bigger just for the demo. Okay. Oh, it's interesting that that changed the font. But anyway, so now you can see our 200, 200 is this middle point right in the middle of the canvas. And the closer my mouse is to that point, the lower that distance value is. So the farther the mouse gets away from the circle, the larger that distance value is. It doesn't matter what direction I go in. It's just going to tell me the overall absolute distance between the mouse and the circle. Okay, so that's the same thing as what's happening here is, we're measuring that distance between where the mouse is and where the center of our circle is. So now we can use an if statement to test whether we're inside the circle or we're not inside the circle. And for this example, we're just going to highlight the circle if we're inside, and we will, not highlight it if we're not inside. So to do that, once I have the distance, I just have to compare that to the size of the circle. So I'm going to say if d for distance is less than 100, if the distance is less than 100, which is the size of our circle, we'll do a yellow fill. And if it's not, we'll keep our default white fill. So now, if my mouse is, I did the wrong number, but that's okay. So you can see we're sort of getting the kind of the right thing, but we're off by a little bit. So for our size, we have to remember that the size is the full diameter of the circle, but what we're really looking at is just the radius, just half the circle, because the origin of the circle is in the middle of our circle, so we only really need half the size. So we'll do, half the size is 50, so we'll do 50 here. Okay, so now you can see if I'm inside the edge of that circle, it's yellow, and if I'm outside, then it's white. Our text disappeared because I changed the color, but there we go. So we see if the distance is 50 or below, we get that yellow fill, and if it's greater, then we don't. So we know if our mouse is inside the circle or not. Okay, so that's the basic logic, and now we want to abstract that into a function so we can have multiple circles. Any questions so far? Okay, so in order to abstract this into a function, we have to break down what are the different parts and turn those into arguments. So the things we need to know are pretty similar to what we would normally need to know about a circle. We need to know where the circle is, because we use that 200, 200, the position of the circle. So that's the x and y value of the circle. And then we need to know the size of the circle, because if the size of the circle changes, then the math changes to determine if we're inside the circle. So the way that I would normally do this is I would make a new function, and then I basically just take each line of code and think about how do I abstract that into my function. So I'm going to make a function for a button, and then we'll just go through each line of code. So the first line is this variable d equals distance. So if we have multiple different buttons, they're going to have different positions. So that x and y is going to be different. So that we know that these numbers are not going to be able to be hard-coded. And so what we can do is start to write our buttons. So I'll write a button here, and then we can think we're going to need these 200 and 200. So I'll copy that and put it into the button. And then we need to think about what variables would be the right variables to capture those numbers. So it depends on what type of function you're making. In this case, it's going to look a lot like our other P5 functions because we're still using position and shape and things like that. So I'm going to grab this distance line, and I'm going to copy and paste it in the first line of my button. And now I have to think about how do I get this 200 to here. So I just add in a parameter, just like we have in our rectangle and ellipse, our P5 functions. I add a new parameter, this X value, and then that X value goes here. So that way I can make multiple buttons with different positions, and that's how I'll get this number from here to here. So then I have another hard-coded number here. That's the Y value. So I know I want this 200 to go into the Y value here. So I'll just add a new parameter and call this Y, and then throw that in there. For mouse X and mouse Y, we could add those as parameters as well if we wanted to have like different inputs. But I'm just going to leave those for this example because we're just going to be using the mouse. We don't have other inputs. So that's our first line of code. We've abstracted these parameters into variables. So now we can delete this and go to our next line of code. So now we have this if statement where basically we're using this distance variable that we calculated here. Let's put a note here that says calculate distance between circle origin and mouse. Okay, so we've got our distance, and now we need to copy this code and abstract the values there. So there's only one value here. Well, there's actually, we could change the color, but let's just focus on the numbers for now. So this 50 is something that we need to determine. And what we know about this is it's half the size. That's what's relevant. But we also want to abstract that value so we can have buttons that are different sizes. So we can use another variable there, which is going to determine our circle size and the distance as well, since those are related to each other. So let's copy this value and paste it here. And then we're going to want to add another input to our button to derive this, this number here. So our value here, we could either use 50 and then we could multiply it by 2 for our circle, or we could use the circle size 100 and divide it by 2 to get 50. Either way, it doesn't really matter, but why don't we put 100 here, and so that'll be the overall size of the button. So then I'll add another parameter to the button. I'll call this S for size. And now we know that this 50 is just going to be half of whatever the button size is. So it's the radius versus the diameter. So we'll do size over 2 here. Okay, so we've abstracted that out. You could add a variable for the color. Let's come back and do that later. So let's get rid of this. And so now we just have one more line of code for our button, which is the circle. So let's copy that and paste it in here. And so now we've abstracted out our X, Y, and size, and so we can just put those in here. So we have X, Y, and size. And let's get rid of our text for now. And so now we've abstracted out everything that makes this button work using our parameters for our function. So now it'll still work exactly the same way, but now I've got a function that I can repeat. And since all of those parameters are, arguments here, I can make buttons with different positions and different sizes, and they'll work the same way. So if I make another button, let's put this in a different position, in a different size. I'm just going to put some random parameters. Okay, so now I have 2 different buttons, but notice they operate independently. So I'm using the same logic and setup, but I've abstracted it, so I can do it multiple times, and I can change the size and position. So now I have 2 different buttons, and I can highlight them at different times. So now you could imagine you could start to create, lots of different applications from this with different outputs. You could have buttons moving at different paces. You could have different interactive components in your user interface. You could have game objects, so you know if you're clicking on an object in the scene. Let's draw another button. We'll just move it. We'll just move it over, maybe 300 on X and 300 on Y, and let's make it even bigger. Make a really big one down here. So we can have different buttons, different sizes, and different positions. So we'll do the same thing with a rectangle, and hopefully that'll kind of like show how the process works a little bit more. We can also change the color. So if I wanted to change the color, I would just add a different argument. So anything that I want to be kind of like unique to the button, I can add an argument for that. So we have this fill is yellow. So if we wanted that to be an argument, I could add yellow here and then replace a new that value with a new argument. I'll use C for color and then just fill C. So anytime I want something to be different in my different buttons, I need to create an argument for that value. So now I'm getting an error because I don't have all my colors. So let's add in other colors. So I can have yellow, I can have blue, I can have purple. Okay, so now I have the same basic logic and the same basic setup, but I have different colors that get highlighted when I hover over the different buttons. So again, we'll repeat this process with a rectangle, but any questions or anything you guys want to review on this example? Did you replace the variable? Yeah, you have to replace.
Just the first few or both of them?
And you have to have that over.
Just the first few or both of them?
Sorry, the first few what?
Should I replace? Because I can only see the first one. You see there if, and then the fill, and then you created the variable C. The other two, the else two, for the color?
You could add so the way it's set up now, the default color will always be white, but if you wanted a different, default color, you could add another variable for that. Okay, so now you're filling that color regardless of where the mouse is. So you can add another argument for that color, or you can just leave it. Yeah. So that's sort of like the default if you're not hovering. But if you want a different color there, you can add another argument. Yeah. Okay. So we'll do something similar, but this time we'll use a rectangle, and we'll see that a lot of the stuff stays the same, but the logic changes, and the logic is a little bit more complicated. So I'm going to add this to our class collection. And we'll create a new example, and we'll call this rectangle button. Okay, so start with a comment again, rectangle button example. So let's go over the logic for the rectangle. So I'll draw a rectangle first. So I have a rectangle. And I could do a square, but I'm going to do a rectangle just to make the example a little more clear. So I'm going to draw a rectangle. I'll start it at 50x and 50y, and I'll make it 100 pixels wide and 50 pixels tall. Okay, so we have a little rectangle, and we want to know when our mouse is inside the rectangle. And so with our circle, it's pretty easy. We just have to measure the distance between the center of the circle and the mouse. But with our rectangle, it's a little bit different because it doesn't have a radius. It doesn't have an origin point the way that a circle does. If we measure the distance from the origin of the rectangle, the top left corner, the distance isn't really going to tell us anything about the relationship between the circle and the mouse. So what we actually have to know is a few different components. And there's a visualization of that here. So here's our rectangle. And if we want to know if our mouse is inside the rectangle, we have to know 4 different things. So one thing is our mouse has to be, greater than the left side of the rectangle. So if our mouse is less than this side of the rectangle, we know it's not inside the rectangle. Same thing over here. If the mouse X is greater than the end of the rectangle, then we're also not inside the rectangle. And then we also have the same thing happening on the vertical axis on the Y. If our mouse Y is less than the value of the rectangle where it starts, we're not inside the rectangle. If it's greater than where the rectangle ends, then we know we're not inside the rectangle. So we have 4 different conditions that we have to check to tell if our mouse is inside of this area. So it's a little more complicated than the circle, but you probably know from experience that most buttons are rectangles, not circles. We can see plenty of examples of that in our Mac interface, in our Chrome interface. There's some circles like this little tab guy. This guy is a circle over here. These guys are circles. But most of these things that we click on are more, rectangular, like our file thing, all these little buttons here, these are all rectangles. So our computer is doing this basic math like constantly over and over and over again to tell what we're clicking on and what we're trying to do. So let's put together all of these parameters. So we'll just start with one, and then we'll add to them. We're going to use very similar logic. So we're going to start with if mouse X, and what we want to know, we know that this is the X value of the button. So we want to know that our mouse value is greater than that 50 value. So mouse X is greater than 50. So if that's true, let's do a fill yellow. And then if it's not, we'll do our default fill white. Okay, so our rectangle is going to be white if our mouse is over here, but when we cross that 50, our rectangle turns yellow. Okay, but if our mouse is up here, it's still yellow. If it's down here, it's still yellow. If it's over here, it's still yellow. We're only checking one condition, which is basically which side of this line, this 50x, is the mouse on. So we have to add some more conditions. And there's different ways to do this. The way that you'll see this most often done in this context is using a compound conditional statement. So we'll add 2 ampersands to say that these things both have to be true, and then we'll just add the rest of our conditions. So the next condition is that our x value for our mouse has to be greater than this line, 50, but it has to be less than this line. And this, we have to do a little bit more math because we know we're going to make multiple buttons. And so we could just figure out what this number is. But if we change the size of the button, then it's not going to matter what this particular button is. It's not going to work if we change the size or if we change other parameters in our button. So the thing we have to know about this button is not just where does the button start, but how wide is the button. Okay, so if the button starts at 50 and it's 100 pixels wide, then we need to know if our mouse is less than that value. So we need to know if mouse X is less than, so we'll start with the 50 of our X, and then we'll add the 100 of our width. And we're gonna make these into variables later, so it's better to just leave them separate for now because they represent 2 different things. One represents the position of the button, one represents the size of the button. So let's test that condition. So now it turns on when we go across this line, and it turns off when we go across that line. So that seems to be working the way we want it to. So that's good, but we still need to do the top and the bottom. So we're going to add some more conditions. Yeah. That's a good question. So the reason I did it that way, I could change this into 150, and it'll work for now. Okay, it's working. But if I have a button that's a different size, let's say I have a button that's 150 pixels, now this button breaks right here. So the reason I'm leaving those values separately is because they represent two different things. One represents the position of the button, that's the 50 or the X, and this represents the size of the button, the width here. So what I want to do later I'm going to abstract these into variables. I want to have those separate because I could also change where the rectangle starts. I could change this number to 200, and now it looks like, you know, the place where the button activates and where the button actually is don't line up visually, and that we want to avoid that. But that's a good question. Okay, so now we're gonna add our Y section. So we have our X section, but we don't have the Y. And this looks almost exactly the same, except now we're talking about vertical Y position and height rather than horizontal X position and width. So I'm gonna add another double ampersand. We can just keep adding these, and each time we add it, we're saying these conditions have to be true. So you can think of these as kind of separating. This is one if rule. This is another if rule. This whole section. We can put whatever we want in between the ampersands. And the ampersands will say basically stop here and evaluate the condition before this, and then look at this next condition afterwards. Okay, so our next statement, we have to look at our Y. So we'll say, we know that mouse Y also needs to be greater than 50. That's where this Y value is. So we can test that pretty quickly. So now you can see this part is no longer highlighting. So now we know 3 of our borders for our button. And we just need to do the last one. And this is gonna, again, look very similar. We're gonna say mouse Y, and we wanna know if it's less than the top, which is 50, and then this time the height is different. The height of the rectangle is 50. So this one is gonna be 50 plus 50. Okay, so now we have the left boundary, the top boundary, the right boundary, and the bottom boundary. So now we know for certain if our mouse is inside of our button. Okay, so now we're gonna abstract this into a function. So we'll call this button again. We don't have to worry about our other button function because we're in a different sketch. So we're gonna call this button, and here we basically need to know the same stuff. We need to know the X, Y, but now we don't have just one size value. We have a width and a height. So this is gonna look a lot like our rectangle function, but it just basically adds this if statement here. So I'm gonna copy these parameters and put them up here. And then another way I can do this is I could just end my draw function here and just make my button function right there. That way I don't have to copy and paste because I know that all of this stuff is gonna go into my button function. So there's different ways to kind of approach different, moving our code around. But now I have to go through and say, how do I get this 50 into the button, and this 50, and this 100, and this 50. So our first 50 is the X value, so I'm just gonna put X here. And then I'm gonna look for all the places where I use the X. So this mouse X is greater than 50 is X. Then mouse X is less than 50 plus 100, this is also X. And then our rectangle down here is drawing it X. Okay, so we've got our first value. Now we move on to Y. So we have Y, and this is mouse Y is greater than Y. Mouse Y is less than Y plus 50. And then we have our rectangle at Y. So then we have the width value. I'm going to use W for that. And so we can see the 100 here is our width, and the 100 here is our width. And then finally we have our Y value, 50, our height value. Or whoops, we want to leave that 50 and just put another parameter here, H. And so the H goes here and the H goes here. Okay, so now we've got our button abstracted and we can make more buttons. So if I want to make another button and just move it down a little bit, but make it the same size, I can do that. So I have two different buttons. And then if I want to make a really long button, I can do that. I'll move it down and make it really long. And this is going to work because we've abstracted our variables so that we can put different numbers in there, but the math is going to work the same. We're always going to check the X is the left side of the button. X plus width is always going to give us the side of the button plus the width of the button. And same thing on the Y side. Y is always going to give us the top of the button, and Y plus height will always give us the bottom of the button. So let's do a button that's a different width and height. So let's do a button. I'll move it way over. So I'll do it at like 350Y, and I'll make it 50 pixels wide, but 100 pixels tall. So this button, even though it's a different, it's taller than it is wide, it still uses the same basic logic. So a lot of programming is just taking some pretty basic logic and then abstracting it, putting it into one function so that we can use it over and over again, but figuring out what are the things that are similar and what are the things that are different. So the things that are similar are the shape that we want to draw and the code that we use to detect if the mouse is inside the button or not. The things that are different are, the position and the size of the button. So this isn't always going to be the case. There's going to be other, areas where your functions are going to be used for different things. And the real sort of work of programming, once you get the basic syntax down, is this type of problem solving, isolating what parts are the same and what parts are different, and then figuring out how do I capture those differences using different variables and different inputs. All right, so that's it for this part of the lesson. We'll have some workshop time so you guys can play around with this and start thinking about what you want to do for your final project. So let's look at that for a second, because what I'm going to cover in the second part of class is building your final project proposal. And we're going to use the button in the sketch as a way to advance. We're basically just going to make like a little slideshow. But you can start thinking about what you actually want to do for the final project proposal. This is very open-ended. A lot of students will take something that they made earlier in the semester and add to it. If you have a project that you liked and you want to make it more interesting or add more components to it, you can do that. Sometimes people put things together, so you have one project that you like and you want to add another sound to it, or you want to add interaction to it, or whatever, animation, you can do that. If you have like a totally different idea and you just want to do something that you just have like an interest in, you can propose that. We might talk about it and see if it's how doable it is, because some things are easy to do and some things are harder to do. But if you think about that a little bit, you can come up with an idea. And then you can also look at, if you go to, this is over here. I should put a link to this. If you look at this student work page, you can see examples of projects that students have done in the past. And these are just kind of like a selection of different projects going back a while. Some of the projects all the way back here are going to be less relevant, although I think they're still kind of similar to what we're doing. This is like a pretty basic video game where you capture these sodas before they hit the fish. This one is pretty advanced, actually, programmatically, but you could probably build something like this if you like something that looks like that. Other things, there's also work from more recent semesters that you'll see look more like our WordPress Open Lab blog, since you can see about here is when we moved to the Open Lab. So you can see if you look at things that are categorized as a final project, you could take a look at some final projects from previous semesters. There's a lot of different stuff in here that might be inspiring. So yeah, I'll put a link to this on the class blog here, so it'll be easier to access. But I'm very open to different ideas. So if you guys have different things that you want to do, just start thinking about what would be interesting. Another thing to think about is having something for your portfolio. So you guys might have different focuses. You might be some of you guys might be interested in programming. Some of you might be more interested in design. Some of you guys might be animation majors. Whatever it is that your focus is, you will eventually want to be able to add stuff to your portfolio. So if you think about things that would look good along with your other work in your portfolio, that might be another sort of way to think about what you want to create for the final project. But yeah, let me know if you have ideas or if you want feedback on stuff, and then how doable it will be. We are going to have a lot of class time to work on this. Like basically our last 2 classes are mostly going to be dedicated to working on the final project. So you'll have a lot of time in class to get feedback on things and to try different stuff. So you can start thinking about that now, and let me know if you have any questions. And at 4, we'll go over creating the project for the presentation. Any questions on any of that? All right. Let me stop